Now, how do you measure intelligence? Well, again, always remember intelligence as a construct. It depends upon how you define it, which will wind up affecting how you measure it. But because we're working with the standard westernized process of intelligence, the typical way in which you're going to measure intelligence is with an intelligence test that has mostly the material from high school on it as a 3-hour exam. It is essentially the same thing as the SAT, but it wasn't always that way. The revision of Binet and Simon's test for academic abilities becomes the Stanford Binet, and the scaling form for the intelligence test actually follows a mental age calculation, which is no longer used. Also note that this mental age calculation was created in 1912. That was 4 years before the Stanford Binet came out. So this concept of a mental age was actually applied to even earlier forms of intelligence tests, which we don't even see any longer. Now, the mental age calculation looks like this. Your IQ was determined originally by taking your mental age, which was essentially your score from an IQ test, and dividing it by your actual age, your chronological age. So most of you are probably 18 years of age, so that's 18 in the denominator. Your mental age was determined by giving you an IQ test and determining your score as an average from a range of ages. So for example, let's suppose you were a 10-year-old. If you're 10, you're given an IQ test, and if you do really well on the IQ test and score really high for a 10-year-old, that high score for a 10-year-old might only be, let's say, an average score for a 16-year-old. So in that case, because the score is equivalent to an average 16-year-old's IQ score, your mental age is determined to be 16. And if you had a mental age of 16, you divide that by your actual age of 10, you'd have a value of 1.6. Take that 1.6, multiply by 100, and you'd have an IQ of 160. If, for example, you were a 6-year-old that was as smart as a 12-year-old, then you would have a mental age of 12. Your chronological age is 6. You take the 12 divided by 6, which is 2, multiply that by 100, and you'd have an IQ of 200. Of course, the same thing would work if you were 18 years of age, but you were only as smart as the average 9-year-old. You would wind up with an IQ of 50, because 9 divided by 18 is 0.5. 0.5 times 100 is going to be a value of 50. Now, this type of mental age calculation was used for a decade or so before it was replaced by other standardized measures we're going to talk about. But before we move on to those, we're going to ask a question about how this actually influences your perception of IQ over the course of your lifespan. What is the main reason the mental age calculation was dropped by intelligence researchers? And the correct answer is C. It does not work with adults who finish their schooling. And the basic way to understand that is, if we played the game that when you graduated from high school, you are not going to experience any memory decay at all. And of course, this is entirely impractical. This is only a thought experiment. But you have straight A's when you graduate from high school, so you've learned everything, and you won't forget anything that you ever learned. Your mental age calculation will continue to decrease your IQ over time because you continue to have birthdays. When your mental age is 18 and your actual age is 18, and you multiply 18 divided by 18 is 1, you multiply that by 100, your IQ is 100. As you have your 19th birthday, your IQ is going to drop down. When you get to age 36, you'll have a mental age of 18, an actual age of 36. You'll multiply that by 100, and you'll have an IQ of 50. And in fact, if you take a look at how your IQ changes over the course of your lifespan, based not on memory decay, but simply on the fact that you're getting older, you see how your IQ is expected to drop over the course of your lifespan. In fact, this idea was actually where the idea that the elderly are stupid comes from. It's a stereotype that early 20th century psychologists gave society because during the 10 years or so that this mental age calculation was used, it was projected that an individual's IQ should drop over the course of their lifespan, and as a result, the oldest people in society should have the lowest IQs. It turns out that this is not true. This is a faulty measure, but it actually has given not just the stereotype that the elderly are not that smart, it has also given you another type of phrase that sometimes still floats around today that people still believe. And that is this: Joe is mentally retarded and has the mind of a 4-year-old. Where would the idea that a person with mental retardation has the mind of a 4-year-old actually come from? Well, it comes directly from this mental age calculation. If an individual is 30 years old, but they do very, very poorly academically, so let's say they have some sort of intellectual disability, and the score that they get on an IQ test is equal to an average 4-year-old, it used to be said that the person had a mind of a 4-year-old. And what that really meant was they simply scored equal to a 4-year-old on an IQ test. To say that they have a mind of a 4-year-old kind of implies too much, that their behavior is going to be exactly like a 4-year-old. And that's not at all true, not even close. 4-year-olds have not gone through puberty, but the 30-year-old individual in our hypothetical example would have. Our 30-year-old individual would have had many more life experiences, many more opportunities to learn. Their patterns of behavior are going to be very different than a 4-year-old. And so the comparison is not a fair one at all. So the idea that when somebody says, Joe's mentally retarded and has the mind of a 4-year-old is inherently an incorrect statement, because it takes the IQ test and it makes that the primary way to understand the individual. And the IQ score is just one tiny little thing. It's a specific way in which you assess intelligence based on the construct for intelligence that you accept, and it ignores all the other aspects of social experience that the person may have actually had. So how do you create or standardize an IQ test? There is a fairly standard way IQ tests tend to be made, especially if you're working with the North American construct for intelligence. One of the first processes that gets used is the process of factor analysis. Factor analysis is a fairly complex statistical test that works just like the Pearson correlation coefficient, except instead of only restricting yourself to 2 variables, you can add as many variables as you want. So, for example, when we worked with the Pearson correlation coefficient in the past, we worked with 2 variables like height and weight. And you can find the correlation coefficient for the relationship between height and weight. But you're stuck at only applying 2 values into that test. With a factor analysis test, you can add as many variables as you want into it. There's no upper limit. So you can add in things like height and weight and gender and grams of protein eaten per day and amount of exercise and age of the individual and a whole stream of other things that are related to connecting these various biological processes. And then the factor analysis test will give you correlational coefficients for all of the possible combinations of variables that there are, like height, weight, gender, protein, and so forth, and all the various combinations of them. And so it's a fairly complex type of test that's actually commonly taught in advanced courses in statistics in graduate school. So it's not something we're going to do here. But these tests are actually kind of at the heart of how IQ tests are actually made, because in an IQ test, many questions are asked and many things like the components of general intelligence are actually going to be assessed. And those things are assessed against other aspects of the intelligence test itself. And so when you create the IQ test, you're always relying on these factor analysis tests themselves. Secondly, there is a need to focus on creating a normally distributed set of results. If you go and measure the skill ability of a person for any type of test, you generally will not see a normal distribution unless the type of test that you're using was originally designed to create a normal distribution. Oftentimes you don't. And not having a normally distributed set of results in any statistical test oftentimes results in problems in being able to decipher the results statistically. As a result, most of the IQ tests that are generated are specifically designed in a way to force a normal distribution to be generated from the results so that the test is easier to analyze. And you do give some things up, as you might imagine. You lose some of the actual way the data look in intelligence testing, and you force things to become on a normal distribution. So there's a trade-out, and those aspects tend to be fairly complicated issues, but these two primary factors, the use of factor analysis and the creation of a normally distributed set of data, are always at the basic underlying components for developing an IQ test. Now, the process of standardization in an IQ test essentially takes place the same way today as it had done way back in the time of the Stanford Binet's creation. You have to find a group that you're going to work with. So let's say it's, you're creating a first IQ test. You start with 10-year-olds and you ask yourself, how much should 10-year-olds know? Well, there's no way to answer that question, right? You have to measure 10-year-olds to know how much information they actually have. So you go out and you measure 10-year-olds on as many different types of intellectual tasks as possible. Then you find averages for the different types of categories of information you're working with, like math ability and language ability, problem solving, memory capacity, and so forth. And then you establish the average from that first group of individuals you work with. And that becomes your standard. And that's nothing more, nothing less than what a standardization actually is. So you'll do this usually with 1,000 or more randomly drawn 10-year-olds to find out what is the average amount of math that they know. Is it the right amount of math? Is that amount of math too much or too little? It is what it is. Whatever you measure becomes your standard, and that's it. And you'll do the same thing with 9-year-olds and 8-year-olds and 7-year-olds and 6-year-olds, and backward in time and also forward in time with 11 and 12 and 13-year-olds, all the way up to the point where you reach roughly 18 to 21-year-olds. And at that point, typically, the IQ tests are not standardized any longer. Of course, they can be standardized for 50-year-olds and 60-year-olds, but those are unique types of tests that we're not going to wind up talking about. Most of the standardizations just run from essentially about birth or the first month of life to about 18 to 21. And that's because during this entire process, you at least have the beginnings of development early in life, and then you get to the later portions of the person's expected academic career. That is them getting out of high school, maybe getting into a little bit of college before you stop the standardization process. And once you have that standardization for any one particular year, you simply use it as the measurement device for all the future people that are going to be taking the test for that age range. So once you make a standard for 10-year-olds, any other group of 10-year-olds the following year, the year after that, the year after that, they're all going to be measured against the 10-year-old standard that you created this year. Of course, as I've mentioned earlier in these lectures, there will come a time where you will have to update your standard because, for example, the standard for the adult in 1916 is not going to be the same standard for the adult in 1966, and that's not going to be the same standard for an adult in 2016. As time goes by, schooling changes, society changes, there's vocabulary words change, technologies change, and you have to update your tests usually about every 10 to 20 years or so to make sure that the standard is appropriate for the group of people you're working with. Now, the normal distribution, which is something we worked with a little bit in Chapter 1, is shown here on this page mainly because it is the primary way in which IQ values or many other types of tests in the behavioral sciences are actually presented. In this case, any IQ test will be designed to generate a normal distribution of scores. And the normal distribution is important because it has the same relative proportion of scores in each of the standard deviation units. So in this particular case, one of the more commonly used intelligence tests, which is the Wechsler Adult Intelligence Scale, is shown on this page. The Wechsler Adult Intelligence Scale has a standard value of 100 for its mean, and it has a value of 15 for standard deviation units. So a value of 115 is one standard deviation above the mean. A value of 130 is two standard deviations above the mean. A value of 145 is three standard deviations above the mean. And of course, you can go under the mean as well. And that would establish where a score exists in its relative standing relative to other people. So if you're using the Wechsler Adult Intelligence Scale and you scored 115, you would be one standard deviation above the mean. Or you could also say you have an IQ that is equal to or greater than 84% of all the individuals who have taken the IQ test. Why 84%? Because 50% are below the mean, and you're one standard deviation above the mean, which is an additional 34%. So 50 plus the 34 is 84. If you were two standard deviations above the mean, then you would have an IQ score that was about 98th percentile. Now, psychologists have taken this continuous change in IQ value from low to high, and they have arbitrarily assigned the value of genius to anyone who has gotten an IQ score above the second standard deviation. Why two standard deviations above the mean? Well, it's somewhat related to a subjective statistical issue. You can just accept the fact that being at the 98th percentile was a satisfactory place to identify individuals you wanted to refer to as geniuses. Could you have made it at the 97th percentile, the 95th percentile, or at the 87th percentile? Yes. This is a completely arbitrary aspect. It's the point that was settled on many decades ago for intelligence researchers and has largely been held this way ever since. This is also, to somewhat, in a bit more of a vague way, where the idea of savant is coming from as well. When we talked about an individual has a savant level of skill, what level of skill actually are they on? Well, now that we're looking at a normal distribution, they do have to be somewhere above the second standard deviation. Now, the definition for genius is squarely placed at the 98th percentile. Savants seem to be a little bit more loosey-goosey in this case. I have never seen a widely accepted idea that you have to be at the 99th percentile or some other such thing. Generally, it appears that most intelligence researchers accept that if you are at the 98th percentile naturally for one particular skill, then you'll be referred to as being in the savant level. But savants oftentimes seem to be much higher in terms of their specific capacity to do something than somebody in a genius level. But again, I mentioned that intelligence researchers really have not established clear definitions for where a savant or a genius would actually be. They have been much more careful about defining genius as being 2 standard deviations above the mean, or the 98th percentile. Savant, a little bit more loosey-goosey. Now, given what we've just talked about with the normal distribution, answer this question. Given the structure of the normal distribution and its use in intelligence tests, what percentage of geniuses exist in any country of the world? And the correct answer is A, 2%. And why is the answer 2%? The answer is 2% because the measure of genius is always at the 98th percentile, the top 2% of a distribution. So it doesn't matter which country you go to, no matter how large or how small it is, there will always be a statistical estimate of the top 2% of that population being established as a genius relative to the rest of the population from that country. So if you take the population from any particular country and find out what it is and then multiply it by 2%, that's going to be the number of geniuses identified in that country. Of course, there's actually another side to this, something that we haven't really talked much about, and that is a intellectual impairment or intellectual deficiency. For individuals with an intellectual development problem, they generally are identified as being the bottom 2%. So you wind up with the same story. How many people would be expected to have an intellectual disability in any country of the world? The answer is, again, 2%, because it's the bottom 2% that would establish those individuals. And so for any given country, 2% are always geniuses, 2% are always identified as having an intellectual disability. And that's simply the way the tests are made based off of the broader format of the normal distribution. Now, the modern intelligence quotient, when you're talking about how it should be defined, have traditionally used the value of 100 as the average for an IQ test, although it doesn't have to be the value of 100. The value of 100 actually, just as a reminder here real fast, comes directly from the mental age calculation. Because in Stern's original mental age calculation, he did not want to deal with decimal places, so he just multiplied the mental age by the actual age and multiplied it by 100 to get rid of any decimal place. That made the value of IQ of 100 the average age, the age when your mental age and your actual age are exactly the same. So many intelligence researchers have kind of held to that same format today, but it doesn't have to be. The SAT, as I mentioned, which is a form of IQ test, has traditionally had a value of 500 as its average. There are other types of IQ tests which have wildly different averages. You simply select a number and make that your average. Most people recognize the value of 100 as being average, and because it simply is an arbitrary selection, most researchers have created IQ tests with a value of 100. Other than that arbitrary value of 100 as a value of IQ, most IQ tests generally have two particular sections, a verbal section and a mathematics section. What test have you generally seen that has a verbal and a math section on it? The SAT, right, and also the GRE, the graduate record exam, which many of you may take years from now. The SAT is really a 3-hour summary of everything that you've learned in high school, placed on one test with an average value of 500, and it's used as a way to assess how much you know relative to everybody else who has graduated from high school, and that score is used as a way to determine whether or not you have learned enough to be able to move on to college. That's essentially the value of the SAT. Of course, if you don't have a good SAT score, you can always do a training program, right? You can get out practice exams and booklets to train yourself, read a book, learn the material again, and pull your score up. The entire business of raising your grade for the SAT or the GRE is based around the idea that you can actually learn this material. And notice that this is very different from the original idea of IQ testing from the early 20th century. In the early 20th century, the original overarching theoretical approach was that everything was based upon your genes. And if your genes determined your IQ, and your IQ was bad, then there would be nothing you could do to increase your IQ. You just measured, you may have been measured with an IQ of 85, and that meant you were going to be stuck with it, so you would never be able to go to college or do anything else that involved intellectual work. The idea has actually changed quite a bit now. Even if your genes do influence your intelligence, it does not negate the possibility that you can actually learn in slow increments and continually gain knowledge. And so there's a much more forward-thinking idea about the whole process of IQ today. If your IQ is low, if your SAT scores are low, you can always work to improve your score over time. Of course, most people will work to improve their SAT score because there's an outcome like getting into college, but I am not aware that most people go have their IQ assessed and then decide that they'll try to raise it. Because, IQ testing is actually a rather expensive thing. Most people generally don't go around doing that because of the cost and time involved. Now, the IQ tests that you see today are generally based around the idea of standardization with respect to age. The original idea was that as you get older, you have to reset the scale to average for an individual after they've had their birthday, because you're always standardizing IQ to an age range. What you typically don't see are things like an IQ test where the IQ starts at 0 for an infant and then just increases progressively over the course of your entire life. Those types of tests don't seem to exist. You always reset the IQ back to 100 after the person has their birthday. And that's just been the traditional way that intelligence researchers have actually worked since the beginning of standardized tests in 1916 with the Stanford Binet. So, for example, if you saw a 10-year-old who had an IQ of 120, so that's a 10-year-old with an IQ of 120, and this 10-year-old has an uncle, a 40-year-old uncle who has an IQ of 100. Who do you think would be smarter? The 10-year-old with the IQ of 120 or the 40-year-old with the IQ of 100? I mean, I would think the 40-year-old is definitely going to be smarter, right? That would be the only thing that would make sense. I would never expect a 10-year-old to be smarter than a 40-year-old. But the way in which the IQ test is actually measured is always specific to age. So as you increase your IQ over the course of a school year at age 10 and 11 and 12 and 13, each time you start the school year the following year, you are given a new IQ test which re-standardizes your level of intelligence back to average, and then you have to start all over again. And that's kind of an odd system, when you think that your intelligence may be increasing over the course of years from year in, year out education. You always keep resetting yourself back to average. It's a little bit of a peculiar system. So if we looked at this question, does a 6-year-old's IQ of 100 reflect an equivalent amount of knowledge as does an adult's IQ of 100? No, they are not equivalent. A 6-year-old and an adult are going to have completely different levels of intelligence. Now, does your IQ remain stable or does it change over the course of your lifespan? This was actually an issue that many of the early researchers grappled with, and they created multiple decades-long studies to evaluate IQ over the course of the lifespan. Because the assumption in the early 20th century, based off of Darwin's theory of evolution, was that intelligence was based off of your genes entirely, whatever your IQ was as a child, it should remain that way for the rest of your life. However, if IQ is based off of the environment, then your IQ should vary over the course of your life based on the amount of intellectual activity that you engage in. What tends to be seen today is that there are skills that tend to be relatively stable over the course of your life. However, they can change if a person actively attempts to change them. And that's true with a lot of skills that we see, even in terms of personality, which is the next chapter that we will get to. In terms of personality, you will see that there are patterns of behavior that tend to be relatively stable over the course of your life. But if a person attempts to change those patterns, then they can change. Some things will change very slowly, some things may change more rapidly, but they are changeable. And that's a story that holds true with intelligence as well. If you're not very good at math now, there's simply no reason to say, oh, I have bad genes for math and therefore I cannot learn math. That is a completely unacceptable answer today. If you're horrible at math and you want to learn math, you can just learn math. And it might be that your genes for mathematical reasoning are not as good as somebody else's, but that's true with all skills. Your ability to run a 100-yard dash, or how empathetic you are to other individuals, or the likelihood that you'll succeed in business and how competitive you are. Those are all different traits, and we're going to reside on a scale with other people, high or low or average, for all these different things. If you have a trait like math ability that you're very poor on now, there's simply no reason that you can't pick up a math book and start training yourself in that skill. And you may progress more slowly than other individuals, but you will still progress. If you put in the time, put in the effort, you will simply get better at it. And that issue, that capacity to change, is a hallmark of current therapeutic thinking in scientific psychology today. The idea that you can change if you try is a very important point for all of therapeutic psychology today. There's no part of current thinking in which you just want to say, well, Joe can't be empathetic to his wife any longer, so we're going to stop asking him to try because he just stinks at it. That's simply not a thing that anybody will do today. And from this process, we'll ask a kind of a general opinion question here. This one really doesn't require a correct or incorrect answer. Have you ever known anyone, including yourself, to feel as though they needed to increase their IQ, so they began practicing to take an IQ test? Most people, I think, would tend to say no, because most people are actually not aware of what their IQ is. If you were to have your IQ assessed formally, it would take about 3 hours, and it would take at least a few $100s. And that would just be the one assessment. So if you went and paid the money and put in the time to assess for your IQ, realized that your IQ was lower than you had hoped it would be, so then you read a bunch of books, and then you went back 6 months later to have your IQ assessed again. It's not a typical scenario that you generally see people engage in. And that very likely is why, in many cases, your intellectual skills seem to stay the same across your life. When people get out of school and they stop reading books and stop engaging academic work, what they do is they remain at a relatively stable level for that intellectual capacity. They don't do a whole lot to increase it or decrease it. They simply move on to a job, and then they get better at that job, and their aptitude for their work will probably increase quite a bit. But how much American history they remember, or anything about Shakespeare, or the amount of math that they remember, may stay relatively stable. Of course, memory always decays over time, so there's going to be loss over time. But it'll seem relatively stable because you remember the memory decay curve. After the rapid drop-off immediately, there's a reasonably stable level at which information is held for the long term. What about the relationship between children and their parents and IQ? Are children more likely to develop IQs similar to the biological parents, or do they develop IQs just based on their environmental experiences? Well, as it turns out, children at an earlier age tend not to have a high correlation between their parents and themselves. But as they get older, the intellectual capacity that they show tends to appear more and more similar to their parents. And what's especially noteworthy in this case is that even if these children have never met their biological parents because they're adopted, or even if their biological parents have actually passed away, they still will show up with an intellectual traits similar to their biological parents, much more similarly than they will to the adoptive parents who actually raised them for 20 years. And that is a type of evidence which supports the idea that a fair amount of your intelligence is actually determined by biology. And this is a long-standing issue in this course. Going all the way back to the Nature-Nurture chapter, we saw that there's a wide range of things that are influenced both biologically and environmentally. And in terms of intellectual capacity, you have to remember that when you say intelligence, it is not one thing. Intelligence comes in many types of aptitudes, the interests you have, and so forth. And the particular interests that you express over the course of your life, the things that you engage in because they're enjoyable, the things that you avoid because you don't like them, play themselves out over the course of your life. And some of those basic motivating factors may be the components that are actually determined biologically. So it's not so much that there's a math gene in your head that was given to you by your mother or your father, but rather some of your ability to do mathematical reasoning may put you slightly above other individuals. And once you do better than other people, you may be socially rewarded for being good at math, which will make it more enjoyable and thereby lead you down a pathway in which you engage in mathematics more often and then very possibly become an engineering student. So what you're seeing is material reflected in what I have been talking about throughout this entire chapter. Intelligence is a construct. The construct means that intelligence is defined from multiple systems. Each of those systems may have multiple genes that create it. So the concept of genetics and its relation to intelligence involves myriad genes, and they have to play themselves out in a variety of different ways through the environment because you have to have opportunities to express those genes, opportunities to learn and engage in tasks. You can ask yourself hypothetical questions like, how many mathematical geniuses actually existed during the Dark Ages in Europe, but those individuals simply had to dig in the dirt and grow plants just to survive and never had an opportunity for any kind of formal education? There are lots of types of skill sets that may simply be ignored because the opportunity is not presented to the individual in the environment. And it's also a thought-provoking process that you can play with. What types of things are our environments not providing us now that would allow for us to express a skill set that we have that we're maybe not even aware of? Will there be, maybe sometime in the future, forms of technology that allow us to express components of our development that we're not really focused on because the way the world exists today? Those are real things, and it's something to consider. Now, the very last thing that we want to focus on is something called the Flynn effect. The Flynn effect was discovered by an economist who was working on how intelligence changed over the course of the 20th century. And the way this Flynn effect actually works is if you take an IQ test from today and you look at the core questions that are still on it from 10 or 20 years ago and eliminate all of the more recent questions and then continue to go back another decade or another 20 years prior to that and look for questions that are still on the IQ from that time and work your way all the way back to 1920 at about the point when the Stanford Binet was originally created. What you will find is a core set of questions that have been on the IQ test since the beginning of IQ tests in 1916. And if you look just at that subset of the IQ test and evaluate the average score over the course of the decades from then until now, you'll find that there has been a continuing increase in IQ value over the course of the 20th century. And in fact, that increase, which is not reflected in this particular graph, has carried over into the 21st century, but currently appears to be slowing down or having possibly stopped. There are many theories as to why the IQ from members of society have been increasing over the course of the 20th century. Many of them are related to aspects of nutrition, changes in society, technology, the public education system, and so forth. In fact, this aspect of increasing intelligence over the 20th century is exactly opposite of what you're always told in mass media, which is television is ruining everyone's minds and everyone's becoming more stupid. And that's absolutely not the case. In fact, the presence of mass media, despite the fact that I will frequently identify mass media as passing bad information around, its broader influence on society has probably been to increase the intellectual capacity of most members of society by distributing information and getting people to become aware of useful information that may wind up on an IQ test that they're going to be evaluated from. So IQ has increased over the course of the 20th century, but this trend seems to be slowing down. So whatever it actually is that has caused it may be maxing out. That's the possibility, but there's a lot of unknowns about what we call the Flynn effect and why it may be slowing down or possibly stopping at the current time. It's an area of current active research, and it's the place where this chapter ends.